Here I have a triangle that has a base of 10, and I don't know the other two sides, but I know the height of the triangle is 6. And this question is asking, if I were to pick a point on one of these sides, and I made a nice perpendicular line and a line parallel to the base, it would create a rectangle. And that rectangle would have some area. And if I picked a different point on the side, maybe up here, that rectangle would have an area which might be different than the area of this rectangle. I could get really long, skinny rectangles like that, or wide. I can get rectangles like that. And these rectangles do not all have the same area. And the question is, which rectangle is biggest? Let me draw this picture again. And the trick to that question, let's just draw, this is a random rectangle, and I'm going to call this side x. And the area of this rectangle is x times whatever the height happens to be. And the trick to this question is that this top triangle is similar to the large triangle. They're similar because this is a rectangle, these are parallel lines, and that would make this angle equal to that angle, for instance. They actually both have this angle here. So because of similar triangles, I could actually work out the height of this top triangle. I can do it with a proportion. In the big triangle, 10 is the base, and 6 is the height. 10 is the base, and 6 is the height. And in the small triangle, x is the base, and for now, let me call h the height. I don't know what x is, but I'm going to solve for h in terms of x, multiply both sides by 6/10, and get h is 6 over 10x, which is also 3/5 x. Well, that's this. But that helps me find the other side of the rectangle, because the entire height, which I put here, is 6. It contains the h plus that other amount. So this other side of the rectangle, the height of the rectangle, this line, is 6 minus 3/5 x. So the area of the rectangle is 6 minus 3/5 x times x, which can be turned into minus 3/5 x squared plus 6x. So depending on how long this side is, we get a different area of the rectangle by this formula. And if I want to know what the maximum is, I'll say max at, since it's a quadratic, negative b over 2a. Negative b is negative 6. 2a is 2 times negative 3/5. Negative 6 over negative 6 over 5, which equals just regular 5. So if I can make this rectangle's width 5, and 6 minus 3/5 of 5 is the same thing as 6 minus 3, which is 3, I would get an area of 15. And it's a pretty hard question, but that is the answer. It's based on similar triangles. Of all the rectangles that I could draw, the one, actually it's right in the middle here, the one where this is 5 and these sides are both 3, with an area of 15, is largest.